can see the stars, which are other suns out there in the galaxy, but they can't see the matter in between them that when you and I were in high school wasn't recognized. Well, see, now they tell us about 95% of the universe isn't shining. Well, that's no big surprise to lay people like me. So anyway, that's the summary on the ideas that are new and old about the universe. Thanks for asking that question, because people use the term without explaining it a lot. And I wanted to say, just like other things change with time, and being old has some advantages and disadvantages. One of the disadvantages is the constants that you learn. When I went back to school to finish up finally, I found out Planck's constant has changed. So I was in there copying this bunch of constants out of an old book, and a young man with his PhD, he walked in. I said, you know Planck's constant has changed? He says, let me see that book. And he said, this book was written in 1966. I'm going, yeah, well, that was like yesterday. Well, the constants change as we get more data. The age of the universe as we calculate it changes. And here is one I wanted to show you that the Hebrew scholar, he come up with 5307. James Ussher came up with this number, Archbishop of whatever, about 6,000 years old. Let's see, do I have another one here? I plotted it up so I don't have to go through all the graphs. But Ussher is right here in approximately 1700. He calculated it at being way down here with the 6,000 years. Buffton, Lyell. Anyway, Lord Kelvin, you probably know about the Kelvin temperature scale. Yeah, you remember? Well, he had a young age to the universe. By the time we get to Hubble, we recognize now it's about 2 billion years old. Gamon calculates it a little older. NASA data puts it at 13.4 billion years old. So the guy who says, he therefore concludes that by the year 3000, if we last that long, the universe will be almost infinitely old. And what it adds up is we don't know how old the universe is. So thank goodness that somebody's able to acknowledge it. And I think, like so many things, we don't know. In fact, after listening to this Bible lecture, I think we know more about the Bible than we know about the universe. But scientists make these measurements, and as I said, when the stars and galaxies disappear over the horizon, we will not know anything about them, because, listen, if you were riding in an airplane going, say, at twice the speed of sound, which is Mach 2, and you decide to shoot a bullet at somebody coming behind you in an airplane going about 300 miles an hour, and you're going twice the speed of sound, and the bullet travels at the speed of sound, your bullet would never get to them. You follow me? And that's what happens with this idea. Once the stars and the galaxies go so fast, they are beyond the speed of light, we'll never see them again, which is just fine with me, since I don't know if I'll worry about that right now. With Social Security on the brink of disaster. Okay, so here we have measurements that have errors, and I thought I'd put that in there. There are random errors, there are systematic errors, and those of you who are studying science in school, you know that we have to deal with those errors, and many times they have an impact on what we're measuring, and they change with the environment. They vary in the object or item being measured. They also vary with the measuring device or instrument or methodology or technology. And of course, they vary with measurement data acquisition and how we record it. So I'm convinced that mankind, as much as we'd like to know, we don't know enough about things. Now I need to go back to just show you a few pictures of galaxies. Let's see, L-O-T. Oh boy. How about 282 once more? And then I'm going to kind of brief it. This is the Hubble telescope, and I'm going to try to brief. These are just pictures I want to entertain you with. Hubble Space Scope is able to see things you couldn't see from Earth. It's a telescope that was put in orbit about the Earth back in November of '89, and Edwin. Wait a minute. No, I'm sorry, wrong. I got to learn how to read better. Edwin Hubble came from Missouri, born in November of 1889, and the Hubble telescope, of course, came in 1990. and it's become one of the most important tools for astronomers. And we thought that things looked blurry from the Earth. They look a little better from the telescope, and there it is up in space. And let's talk about, it can be observed. We find that ultraviolet light that's absorbed by the air and the ozone layer is sometimes disadvantaged when we're looking at things. There's a picture of our Milky Way. I promised to talk about the Milky Way, and that's a picture of it looking from a panning view. If you were sitting out there in space looking at it on edge, this is how we measure the recession. You wonder, how do you know that stars and galaxies are moving away? Now, one of the jobs Leo talked about I had was an emission spectrochemical analysis. That was simply a method of making a sample spark or arc. In other words, you cause this sample that I have here, this unknown sample, to give off light by sending a spark or an arc to make it give off light like the sun does. And we analyze that light through a spectrograph using a prism or a grating, and we look at the color given off by every one of the 108 elements has a distinct spectrum. I know some of you know that because I could tell some of your science majors. It has a fingerprint based on the electronic configuration. So what scientists from Newton and on down have done is they say, if we look at the sun and we see a distinct spectrum that we can identify in the sun has a lot of sodium in it. By the way, if you want to see a spectrum of sodium, you have a gas stove at home, just sprinkle some salt when your mom's not watching over the flame, and you'll see the bright orange like these sodium lights used to give off. Or in the case of mercury, now don't play with mercury because it'll damage your brain. But if you, I was caught playing with mercury when I was a kid, and if you can see the results right now, you're going to end up like me, okay? My mom walked in and saw me playing with a broken mercury thermometer. Oh, she went hit the ceiling. I thought it was cool. But don't play with mercury. But if you look at mercury lights, you'll see that kind of blue, whereas sodium is kind of red. So what happens is each element has its own characteristic spectrum, or let's say fingerprint. And if we look at, that's silver, by the way, those heavy lines are silver. Now, what I'm going to show you is, this is a spectrum viewed from Earth, where we sit here sort of on planet Earth, and we look out at these galaxies and nebulae, and this is the one that you see with the edge of the universe. If we have a stationary detector on planet Earth, and we see that a certain frequency, this represents the frequency of the light, and that's like 10 to the 19 waves per second coming into our detector. And we say if we're moving, if that planet or star is moving, we see that light coming in at about a certain frequency because it has a certain speed. However, if the planet or star is moving faster, I stopped it. I want to make it go faster. There you go. It's coming in faster, like a train when it's coming at you going, ooh, and then when it passes you, the frequency will go down, the same sound even lower. So when the frequency shifts, when the star or bright object galaxy is moving away from you, these waves will stretch out, increasing wavelength increasing wavelength or decreasing frequency. So that's what happens when you look at a frequency shift, and that's how we can actually measure whether a star is moving faster and faster each year. That's why I say coming toward you, but we don't have them coming toward us, they're moving away. And I think I talked about that in galaxies. We have galaxies defined this way in the early in this century. There was a great debate as to the nature of a nebula. And like this one, which was at the time could not be resolved into individual stars. Thanks in large part to the work of the Edwin Hubble and the famous paper, The Realm of the Nebula, finally put the issue to rest. We now know that